Hi all, very happy morning to each and every one who is live right now. I hope audio is clear. There are no streaming or buffering issues. Very interesting class we are going to discuss right now. Very interesting class we are going to discuss. Kindly let me know in case if you are finding any audio issues or streaming issues. Kindly let me know. All the students are very good concepts we will discuss on this Sunday. Very happy morning to each and every one. I hope you can see me live. Kindly reply with yes in case if audio is perfectly okay. Are you facing any audio issues? Are there any streaming issues? I hope there are no audio issues, there are no streaming issues. Very interesting class we are going to discuss today. You will get to learn a lot of new concepts. Are we all ready to go? Kindly reply with yes. In case if you can see the session, students can watch this session in the mobile app. Please click on the home screen. Kindly click on the home screen. In the home screen top, you will find a live class happening. Click on the live button. Click on the live button and you can watch the class. Very interesting class we are going to discuss right now. To all the students who are attending right now, Manisha, Pravalika, Sindhu, Ragamayi, Satvika, Vinay Kumar, right? Very happy morning to each and every one. Very happy morning. Shall we all start the class? Now, without wasting time, we will discuss the class. Today we are going to discuss this concept, perfect square. Perfect square is what we are going to discuss today. Perfect square, very important topic. Most of the students thinks that this topic is a complicated concept. It is not a complicated concept. Once you understand, it is a very easy concept. Perfect square. What we will do is, first we will understand the concept, then we will solve one by one all the problems. Perfect squares. 1 hour class, very good problems. We are going to solve some of the toughest questions in number system question can be solved very easily by using these perfect square concept. Let us not waste time. Concept. What do you mean by a perfect square? First one, a number multiplied by itself. A number multiplied by itself. It is called a perfect square. A number multiplied by itself, it is called a perfect square. For example, 8 into 8. 8 8s are 64. 64, it is a perfect square. 13 into 13, 169. 169, it is also a perfect square. A number multiplied by itself, it is called a perfect square. Take any natural number multiplied by itself, then it becomes a perfect square. Next one. A perfect square means number multiplied by itself. So, perfect square power will also always be an even number. The power of a perfect square will always be an even number including 0 because 1 is a perfect square. A perfect square power will be an even number including 0. Suppose for example, 64 it is there. 64 can be written as 8 square. 8 square it is a 64. Suppose it can be written as 4 power 3. 4 can be written as 2 square power 3. 2 power 6. 2 power 6. If a number is a perfect square, then if you are making it into a prime basis, power will be always be an even number. Perfect square, power will always be an even number including 0, right? Including 0. Why? Because a power 0 is 1. 1 power any natural number, it is 1. 1 power any natural number, it is 1. I hope the idea it is clear. A perfect square, number multiplied by itself, it is a perfect square. The power of a perfect square will always be an even number. Third important key point. Third important key point. A perfect square will always be of the form either 4x or 4x plus 1. Perfect square will always be of the form 4x or 4x plus 1. A perfect square means it is a square of a natural number. It is a square of a natural number. N can be an even number or n can be an odd number. N can be an even number or n can be an odd number. If it is an even number is divisible by 2. 2k square. 4 into any number, it is divisible by 4. If n is an odd number is of the form 2k plus or minus 1 whole square. 2k plus or minus 1 whole square. 2k whole square. 4k square divisible by 4. 2 into 2k, 4 into any number divisible by 4. Remainder 1. Any perfect square is a square of a natural number. A natural number can be an even number or it can be an odd number. If it is an even number, so 2k whole square, 4 into any number. Or if it is an odd number, 2k plus or minus 1 whole square, 4k square plus or minus 4k plus 1, 4k square plus or minus 4k plus 1, 4k square it is divisible by 4, 4k it is divisible by 4, remainder it is 1. Third point, very very important form. A perfect square will always be of the form 4 into something or 4 into something plus 1. A perfect square will always be of the form 4 into something or 4 into something plus 1. Third point, I hope it is clear. First we will write down all the properties of a perfect square, then we will get into the problems. Once we understand the concepts, then application of concepts will be very very easy. Perfect squares. Perfect square. If k is a perfect square, if k is a perfect square, it will be of the form either 4 into something or 4 into something plus 1. 4 into something or 4 into something plus 1. For example, is 1354 a perfect square? Is 1354 a perfect square? Listen carefully, sir. What we need to do is, what is the divisibility rule of 4? Last 2 digits should be divisible by 4. 54. 54 is 4 into 13 plus 2. If it is a perfect square, it should be of the form 4 into something or 4 into something plus 1. 54 is 4 into 13 plus 2. So answer for this question is no. Answer for this question is no. I hope the idea it is clear. Suppose for example, it is 7379. A perfect square is 7379 a perfect square. If right, 7379 a perfect square. 79 is 4 into 19 plus 3. Perfect square is always of the form 4 into something or 4 into something plus 1. 4 into 9 plus 3. What will be the answer? No. What will be the answer? No. I hope you all can understand the concept. I hope you all can see the screen. Any doubts are there? Kindly mention. Any doubts are there? Kindly mention. Any doubts are there? Anybody facing any streaming issues? I think Pravalika says streaming problem is there. Is it clear right now? I hope we have solved the problem. Kindly refresh the page in case if you are not able to see the screen. Is my audio clear right now? Are we visible? Are we visible? Everybody kindly reply. A perfect square when divided by 4, right, it is perfectly divisible or it gives a remainder 1. 1354, 54 is 4 into 13 plus 2, 4k plus 2. So answer for this question is it cannot be 4k plus 2. It cannot be 4k plus 2. So the answer is no. 17, 4 into 19 plus 3, 4k plus 3, it is not possible. Another important property. Concept. I hope it is clear. Next concept. A perfect square. Another two important concepts. A perfect square never ends with. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. If a number is a perfect square, it will never end with 2, 3, 7 or 8. Why? We will see. Unit digit of a number. Unit digit of a number is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 square it is 0. 1 square it is 1. 2 square it is 4. 3 square it is 9. 4 square it is 16, 6. 5 square it is 25, 5. 6 square 36. 7 square 49. 8 square 64. 9 square 81. Anywhere after squaring, if you take a unit digit of a number, it will have all the possibilities from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It will have all the possibilities from 0 to 9. After squaring, anywhere I got 2, anywhere I got 3, anywhere I got 7, anywhere I got 8, no. So if a number is a perfect square, if a number is a perfect square, if a number is a perfect square, it will never end with which all numbers? 2, 3, 7 or 8. Another very important property of a perfect square. Some example is 1, 3, 4, 5, 2. 1, 3, 4, 5, 2. Is it a perfect square? It is ending with which number? 2. It is ending with which number? 2. So therefore answer it is no. Therefore answer it is no. Is 5, 7, 9, 1, 8. Is it a perfect square? Is it a perfect square? It is ending with which number? 8. So the answer will be no. What is the another important property of a perfect square? A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. I hope the concept is very, very clear to you. Another important last property, then we will get into the problems. Property. Every perfect square has a digital sum. Every perfect square has a digital sum 1, 4, 7 or 9. Every perfect square has a digital sum 1, 4, 7 or 9. Reverse may or may not be true. Reverse may or may not be true. What do you mean by reverse? Any number with a digital sum 1, 4, 7 or 9 may or may not be a perfect square. Very, very important concept. Every perfect square has a digital sum 1, 4, 7 or 9. If a number is a perfect square, it should have digital sum 1, 4, 7 or 9. If a number is a perfect square, it should have digital sum 1, 4, 7 or 9. All the numbers with a digital sum 1, 4, 7 or 9, it may or may not be a perfect square. It may or may not be a perfect square. Suppose for example, if I take 133. 133 digital sum is 7, but it is ending with which number? 3. If a perfect square, can it end with 2, 3, 7 or 8? No. So it is not a perfect square. It is not a perfect square. It is not a perfect square. Listen carefully to the concept. If the number is a perfect square, if the number is a perfect square, it will have digital sum 1, 4, 7 or 9. It will have digital sum 1, 4, 7 or 9. I hope the idea it is very, very clear to you. If a number has got a digital sum 1, 4, 7 or 9, it may or may not be a perfect square. But if it is a perfect square, then the digital sum will be 1, 4, 7 or 9. Proof. You take any number, digital sum is defined as sum of the digits until you get a single digit number. What are all the single digits possible? 1, 2, 3, 4, 5, 6, 7, 8, 9. Digital sum is defined as sum of the digits until you get a single digit number. What is this 1? 1 digital sum is 1. 19, what is the digital sum? 1 plus 9, 10. 10 digital sum is 1 plus 0, 1. Suppose if I take 991, 9 plus 9, 18, 18 plus 1, 19, 1 plus 9, 10. This is the set of all the numbers whose digital sum is 1. This is the set of all the numbers whose digital sum is 2. Set of all the numbers whose digital sum is 3. Set of all the numbers whose digital sum is 9. So 1 square it is 1, 2 square it is 4, 3 square it is 9, 4 square it is 16, 16 digital sum is 7. 5 square it is 25, 2 plus 5 it is 7. 6 square 36, 3 plus 6 it is 9. 7 square 49, 4 plus 9 13, 1 plus 3 4. 8 square 64, 6 plus 4 10, 1 plus 0 1. 9 square 81, 8 plus 1 9. 8 plus 1 9. Now if you observe, what are all the possible digital sum we got? 1, 4, 7, 9. 1, 4, 7 or 9. Digital sum is defined as sum of the digits until you get a single digit number. So all the single digits possible are from 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 square 1, 2 square 4, 3 square 9, 4 square 16 which is 7, 5 square 25, 2 plus 5 7, 6 square 36, 3 plus 6 9, 7 square 49, 4 plus 9 13, 1 plus 3 4. 8 square 64, 9 square 81. 81 is 8 plus 1 9. If a number is a perfect square, it will have digital sum 1, 4, 7 or 9. Till here, any doubts are there? What are the important properties of a perfect square? A perfect square, power will always be an even number. A perfect square, when divided by 4, either remainder 0 or remainder 1. Any perfect square never ends with 2, 3, 7 or 8. Every perfect square, digital sum will always be 1, 4, 7 or 9. 1, 4, 7 or 9. One, 4, 7 or 9. Any doubts are there till here? Is everything clear? Kindly reply if everything is clear. Everything, if it is clear, kindly reply. Let us get into the problem solving. If any doubts are there in any of the concepts, I am looking into the comments, kindly reply. Any doubts are there? So Satvika says clear, other students also kindly clear. All the students who are watching the class, Shivani kindly reply, Bhavana, Pravalika, Shyam, Rohit Raj, everybody kindly reply in case if you got any doubts. Once the concepts are clear, then we will get into the problem solving. I hope this idea it is perfectly clear, right? Next one. Now let us get into the problem solving. Now let us solve some very, very good questions. Some questions. See the first question. Consider the following statements. No integer of the form 4k plus 3. K is an integer. It can be expressed as the sum of two squares. That means there are two numbers squares. X square plus y square. It is equivalent to 4k plus 3. It is not possible. He is asking. Not possible, he is asking. Let us see. X square is one perfect square. Y square is another perfect square. Any perfect square will be of the form either divisible by 4 or it gives a remainder 1. Any perfect square is of the form either divisible by 4 or it gives a remainder 1. 4 into something plus 4 into something. Answer will be divisible by 4. 4 into something plus 4 into something. Yes, it gives a remainder 1. It gives a remainder 1. 4p plus 1 plus 4k. 4p it is divisible by 4. 4k it is divisible by 4. It gives a remainder 1. Plus 1, it gives a remainder 2. So, what are all the cases that are possible? If you add two perfect square, every perfect square is perfectly divisible by 4 or it gives a remainder 1. One perfect square will be perfectly divisible by 4 or it gives a remainder 1. Another perfect square will be perfectly divisible by 4 or gives a remainder 1. So, remainder 1. The maximum remainder that is possible, it is 2. Maximum remainder that is possible, it is 2. But here it is 3. So, it is not possible. Statement 1 is right. Statement 1 is right. For example, if the question is x square plus y square equivalent to 127. X and y are natural numbers. X and y are natural numbers. How many values x and y will take? 127. 4 6 are 24 plus 3. 4k plus 3 form will not arise. So, answer for this question is 0. Answer for this question is 0. Why 4k plus 3 form will not arise? Maximum a perfect square gives is a remainder 1 when divided by 4. It gives a remainder 1 when divided by 4. 1 plus 1, 2. Maximum remainder it is 2. 127 is giving a remainder 3. One more question. X square plus y square equivalent to, and so on. Last two digits it is 15, 9. X and y are natural numbers. X and y are natural numbers. How many values x, y will take? 15, 9. 59 it is. 4 14s are 56 plus 3. 4k plus 3 form. It will not arise. Answer for this question is 0. These looks like a complex questions, but once you understand it is very, very easy. Once you understand it is very, very easy. I hope the idea it is clear. Second one. So, sum of two perfect squares can never be of the form 4k plus 3. Second one. Square of an integer, an odd integer, any odd number is not perfectly divisible by 2. It gives either positive remainder 1 or a negative remainder minus 1. So, this will become 4k square plus or minus 4k plus 1. Are you all with me? Odd number is of the form 2k plus or minus 1. 2k plus or minus 1 whole square. 4k square plus or minus 4k plus 1. So, this will be 4k into k plus 1. K plus 1 plus 1. Till here it is clear, right? K and k plus 1. K and k plus 1 are two consecutive numbers. Two consecutive numbers product, it is always even. 2 into 3, 6, 6 is an even number. 3 into 4, 12, 12 is an even number. 5 into 6, 30, it is an even number. K into k plus 1, it is always even. Even into 4, divisible by 8. 8k plus 1 form, it is also possible. It is also possible. So, which of the following statements are right? Both 1 and 2 are right. A square of an odd number. Odd number is of the form 2k plus or minus 1 whole square. 2k plus or minus 1 whole square. 4k square plus or minus 4k plus 1. 4k common. 4k into k plus 1 plus 1. K into k plus 1. These both are consecutive. Consecutive, it is always divisible by 2. 2 into 4, 8. 8 into something plus 1. So this is true and it is also true. You can take some random examples. If I take an odd number 3, 3 square 9. 9 when divided by 8. 8 ones are 8, remainder 1. 5 square 25. 25 when divided by 8, remainder 1. 7 square 49. 8 6 are 48, remainder 1. I hope the idea it is clear. So 1 and 2 both are right statement. Every question whatever we will discuss in the class is an exam oriented question, a conceptual question. Pay maximum attention to it. Next, second question. If k is a positive integer, positive integer means it is a natural number. Positive integer means it is a natural number. Every square, a perfect square will always be of the form 4k or 4k plus 1. 4k or 4k plus 1. Every square of the integer. If I square an integer, it is called a perfect square. Every perfect square, it is of the form 4 into something or 4 into something plus 1. 4 into something plus 4 into something plus 1. Idea it is clear. Next one. N equivalent to 1 plus x. X is the product of 4 consecutive integers. N will be a. X is the product of 4 consecutive integers. X is the product of 4 consecutive integers. You can do it in multiple methods. Method 1. Substitution. You substitute any 4 random values and check it out which is satisfying. X is the product of 4 consecutive integers. 4 consecutive will be 1 into 2 into 3 into 4. N equivalent to 1 plus x. 1 plus x. So 1 plus 1 into 2 into 3 into 4. 2 3s are 6, 6 4s are 24. 24 plus 1, 25. 25 it is a perfect square. 25 is a composite number. 25 is an odd number. So what is the answer? Answer it is a perfect square. Answer it is a perfect square. Method 1. Just take some random examples. I took 1 into 2 into 3 into 4. If you take 2 into 3 into 4 into 5. 4 into 5. 4 5s are 20. 26 are 120. 120 plus 1, 121. 121 it is a perfect square. Method 1. This is a substitution method. Method 1. It is a substitution method. Method 2. Product of 4 consecutive. Let that 4 consecutive will be a plus 1, a plus 2, a plus 3. Let the 4 consecutive will be a plus 1, a plus 2, a plus 3. So n equivalent to 1 plus a into a plus 1 into a plus 2 into a plus 3. A plus 1 into a plus 2 into a plus 3. If I take first and last, second and third. So n equivalent to 1 plus a into a plus 3, which is a square plus 3a. A plus 1 into a plus 2. A square plus 3a plus 2. A square plus 3a plus 2. A square plus 3a, if I call it as p, here it is p. So n equivalent to 1 plus p into p plus 2. So these p plus 1 square. If the power is an even number, then the number is a perfect square. Another way of solving it. N is always a perfect square. N is always a perfect square. A plus 1, a plus 2, a plus 3. A into a plus 3. A square plus 3a. A plus 1 into a plus 2. A square plus 3a plus 2. A square plus 3a. I used it as p. Here it is p plus 2. So 1 plus p into p plus 2. P square plus 2p plus 1, which is p plus 1 whole square. Power is an even number, then the number is a perfect square. Then the number is a perfect square. I hope it is clear. Second example, another exam oriented question. I hope it is clear. Kindly reply in case if it is clear to you. Second example, I hope it is clear. Third one. N is a 3-digit number. N square it is n square. A number on square, it is ending with 94. Number on square, it is ending with 94. How many values of n are possible? 94. Last two digits is 94, which is 4 into 23. For 23s are 92 plus 2. For 23s are 92 plus 2. 4k plus 2 form. 4k plus 2 form is not possible. Any perfect square is always of the form 4k or 4k plus 1. Any perfect square is always of the form 4k or 4k plus 1. It is 4 into 23 plus 2. It is not possible. Answer is none of the values are possible. No values, no natural number on square will get a form 4k plus 2. Any perfect square will be of the form 4k or 4k plus 1. 4k or 4k plus 1. I hope it is clear. Next one. The 10th place digit of a perfect square. There is a number p on square. It is a perfect square. This is a units place and it is a tens place. 10th place of a perfect square, it is 7. 10th place of a perfect square, it is 7. How many possible values are there for the unit digit? 10th place, it is given as 7. How many possible values exist for a unit digit? First of all, it is a perfect square. A perfect square unit digit cannot be 2, 3, 7 or 8. A perfect square unit digit cannot be 2, 3, 7 or 8. It cannot be 0. A perfect square always has even number of zeros. A perfect square always has even number of zeros. A perfect square always has even number of zeros. A perfect square last two digits is always 25. A perfect square last two digits, it is always 25. A perfect square last two digits, it is always 25. It cannot be 5. 5 square 25. 15 square 225. 25 square 625. It cannot be 5. It cannot be 0. It cannot be 5. It cannot be 2, 3, 7 or 8. It cannot be 1. Why? Because if it is 1, it will become 71. 71 is 4 into 17 plus 3. 68 plus 3, 71. So 4k plus 3 form not possible. It cannot be 4 because it becomes 74. 4 into 18 plus 2, 4k plus 2 form, it is not possible. It cannot be 9. Why? Because if it is 9, 4 into 19 plus 3. 4 into 19 plus 3. 4 19s are 76 plus 3. 4k plus 3. It is also not possible. So the only case possible is units place has to be 6. Units place has to be 6. Very, very good question. The 10th place of a perfect square, it is 7. Units place of a perfect square can never be 2, 3, 7 or 8. 2 eliminated, 3 eliminated, 7 eliminated, 8 eliminated. It cannot be 0. Why? Because a perfect square always has even number of zeros. A perfect square last two digits is always 25. So it cannot have 5. 1 not possible. 71 will give 4 into 17 plus 3. 74 will give 4 into 18 plus 2. 79 will give 4 into 19 plus 3. 149 not possible. So the only case possibility is 76. Only case possibility is 76. I hope the idea it is clear. Next one. Idea is just understand the fundamentals and go step by step. AB phi n. AB phi n is a perfect square. AB phi n, it is a perfect square. How many values of n are possible? How many values of n are possible? The root cause of the problem is it is a perfect square. The root cause of the problem is it is a perfect square. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 5. A perfect square can never have single 0. A perfect square last two digits is always 25. So 5 cannot possible. 0 not possible. 5 not possible. 2, 3, 7 are 8, not possible. If n is 1, 51. 4 into 12 plus 3, 4k plus 3, 4k plus 3 form, not possible. So 1, it is not possible. 4, if I keep 4, 54, 54 is 4 into 13 plus 2, 4k plus 2, it is also not possible. Next one, if I keep 9, 9 means 15, 9, 4 into 14 plus 3, 4k plus 3 form, not possible. 0 not possible, 1 not possible, 2 not possible, 3 not possible, 4, 5, 7, 8, 9 not possible. So how many values n can take? Only one value, and the value is 6. Only one value n takes, such that this equation value AB phi n is a perfect square. How many values n can take? It is a perfect square. Is the idea clear? Everybody kindly reply if the idea it is very, very clear to you. Any doubts are there? Kindly ask me. Do you have any doubt? All the students who are attending the class, I am looking at the comments right now. Simple application of properties. AB phi 1, it is a perfect square. A perfect square never ends with 2, 3, 7 or 8. It cannot end with single 0. It cannot end with 5 and tens place is 5. 1, 4, 9. 51 is 4 into 12 plus 3. 54 is 4 into 13 plus 2. 59 is 4 into 14 plus 3. 149 not possible. Everybody, I hope the idea it is clear. Now, if you see here, another question. There are 33,151 men are there. They want to form a square. Square it is p square. How many army men? How many army men should I add it? They want to add. How many army men will be remaining? Remaining means, suppose for example, if these number, there are certain number of army men, they want to form a square. How many army men will be remaining? Now if you see 33,151, 33,151 to add how much number, how many more army men to be added to get a perfect square? If the question is like this, let us go with this one. Suppose if the question is, there are 33,151, how many more army men I should add it? How many more remaining army men will be added? First we will do this question. Added such that they can form a square. 33,151 plus 27. 1 plus 7, 8. A perfect square never ends with 8. So the first number 27, it is not possible. Are you all with me? First I am changing the question. 33,151. How many more army men should be added so that it forms a perfect square? So if it is 7 is giving 1 plus 7, 8. 1 plus these also 8. So these also not possible. 33,151 plus 22. If I add it, this will become 33,176. 33,176. If you observe carefully, digital sum of a perfect square, digital sum of a perfect square is always 147 or 9. Digital sum of a perfect square is always 147 or 9. 6 plus 3, 9. 9 plus 3, 12. 12 plus 1, 13. 13 plus 7, 20. 20 digital sum will be 2. 20 digital sum will be 2. The digital sum of these number will be 2. But what is the concept? Digital sum of a perfect square should always be 147 or 9. 22 not possible. If I take 33,151 plus 25. So this will become 33,176. 6 plus 7, 13, 14, 14 plus 6, 14 plus 6, 20. 20 digital sum, it is 2. So how many more army men to be added in the given option, that is a perfect square? None of them, it is the answer. So answer will be None of these. Answer will be none of these. I changed the question. 33,151 army men are there. How many more army men should be added such that it forms a perfect square? 33,151 plus 27. 1 plus 7, it is 8. A perfect square cannot end with 8. So, unit digit 7, A, option A not possible. Option C not possible. Option D, 33,151 plus 22, 33,176, 6 plus 3, 9, 9 plus 3, 12, 12 plus 1, 13, 13 plus 7, 20, 20 digital sum is 2, 20 digital sum 2. A perfect square digital sum will always be 1, 4, 7 or 9. So, 22 not possible. Similarly, 25 also not possible. Suppose how many more army men should be subtracted such that it becomes a perfect square. Now, if you see here, 33,151. What is the digital sum of this number? I hope you got the logic. 5 plus 3, 8. 3 plus 1, 4. 4 minus, first option, 27. 4 minus 9. Minus 5. Minus 5 means negative remainder. If you get minus 5, add 9 to it in case of digital sum. 33,151. 5 plus 3, 8. 8 plus 1, 9. 3 plus 1, 4. 27 digital sum is 9. 4 minus 9 minus 5. Negative remainder minus 5. Positive remainder will be 4. So, 4 it is possible. Suppose if I take 25. 25 digital sum is 7. 4 minus 7 minus 3. Negative remainder minus 3. Positive remainder 6. It is not possible. Are you all with me? 4 minus 17 digital sum is 8. 4 minus 8 minus 4. Minus 4 means 9 minus 4, 5. Third option not possible. I hope the idea it is clear. Same question. It can be added how many army men, how many subtracted army men. If it is, just remember the rules. A perfect square never ends with 2, 3, 7 or 8. A perfect square always will have digital sum 1, 4, 7 or 9. A perfect square always has a digital sum 1, 4, 7 or 9. I hope the idea it is clear. Next one, another very good question. X square minus 5y square equivalent to 1432. X square minus 5y square equivalent to 1432. How many values x and y can take such that this equation is satisfied? X square minus 5y square equivalent to 1232. The first root cause of the problem is this number is multiplied by 5. If it is multiplied by 5, unit digit will always be 0 or 5. 5 into any number. 5 4s are 20. 5 5s are 25. Unit digit is either 0 or 5. Unit digit is 0 or 5. Right hand side, unit digit it is 2. Right hand side unit digit it is 2. Something minus 0 is 2. That something unit digit is 2. 2 minus 0 it is 2. Something minus 5 is 2. That something unit digit it is 7. Something unit digit it is 7. But x square it is a perfect square. X square it is a perfect square. A perfect square will never end with 2 or 7. So answer is no value of x comma y. Answer is no value of x comma y satisfies this equation. No value of x comma y satisfies this equation. X square minus 5y square equivalent to 1432. Root step number 1. 1432 unit digit it is 2. It is 2. 5y square, 5 into any number, unit digit will be 0 or 5. 2 minus 0 it is 2. 7 minus 5 it is 2. X square unit digit it is coming out to be 2 or 7. A perfect square will never have a unit digit 2 or 7. Very good problem. I hope you enjoyed it. Next one. A 4-digit number is of the form AABB. There is a 4-digit number it seems which is of the form AABB. AABB. This is a perfect square. This is a perfect square. This is a perfect square. Find the value of a plus b. What is the value of a plus b? A, it is a perfect square. B is a perfect square. So if it is a perfect square, it can never end with 2, 3, 7 or 8. It can never end with 2, 3, 7 or 8. Now, it can never end with 5. Why? Because if it is 5, this will also be 5. If it is 1, this will become 11. 4 into 2 plus 3, 4k plus 3 form. It is not possible. If it is 6, this will become 66. 4 into 16 plus 2. Perfect square is always of the form 4k or 4k plus 1. It is not possible. If it is 9, 99. 4 into 24 plus 3. 4k plus 3. This form not possible. So if it is 0, it is also not possible, because if it is 0, 0, 0, 1100, 2200 and so on up to 9900. 1100, 2200 and 9900. Here if you take these 11 into 10 square, these is a perfect square. 11 contains only singular power of 11. Perfect square should have another 11. 2 into 11 into 10 square. 22. It is not a perfect square. 11 ones are, 11 twos are, 11 99s are. For it to be a perfect square, so there has to be a even power for 11. Even power for 11. So 0 also not possible. 0 not possible, 1 not possible, 2, 3, 5, 6, 7, 8, 9. So what is possible? 4 is possible. Last 2 digits it is 44. Last 2 digits it is 44. There is a logic. X square 50 plus or minus x whole square. X square 50 plus or minus x whole square. 100 plus or minus x whole square. 100 plus or minus x whole square. Last 2 digits will be same. Last 2 digits will be same. X square 50 plus or minus x whole square. 100 plus or minus x whole square. Last 2 digits will be same. Let us first see some examples. 12 square is 144. 50 minus 12. 38 square is 1444. Last 2 digits is also same. You take a number, square it. 50 minus x square, 50 plus x square. 100 minus x square, 100 plus x square. Last 2 digits is always same. Last 2 digits is always same. So here the last 2 digits is 44. 12 square is 144. 50 minus 12 not possible. 50 plus 12, 100 minus 12. 100 minus 12 is 88 square. 88 square is 7744. 88 square is 7744. I hope the idea it is clear. Idea it is clear, right? 7744. So 7 plus 4. Answer for this question is 11. Two important concepts we need to know. We need to know the properties of a perfect square, and x square 50 plus or minus x whole square, 100 plus or minus x whole square. Last 2 digits will always be same. 11 square 121. Last 2 digits is 21. 50 minus 11, 39 square 1521. 50 plus 11, 61 square 3721. Last 2 digits is again the same. So last 2 digits is 44. 12 square is 144. 50 minus 12 is 38 square, which is 1444. So but I want AA to be the same. So 88 square is 7744. 88 square is 7744. Kindly watch these class again so that you will have a very good understanding of the concept. N is a 3-digit number. N square will result in 54. Last 2 digits is 54. 4 into 13 plus 2. 4k plus 2. N square is a perfect square. A perfect square will always be of the form 4 into something or 4 into something plus 1. 4 into something plus 2. Not possible. Answer for this question is no value. Answer for this question is no value. Once you understand the properties of perfect square, these all will be very easy. AB to n, AB to n, it is a perfect square. AB to n, it is a perfect square. How many values of n are possible? We have done the similar question few minutes before. Let us do the similar question. AB to n, it is a perfect square. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. A perfect square always will have even number of zeros. So 0 not possible. 0 not possible. 9, is it possible? If it is 9 is right. 23 square is 529. 9 is possible. Possible values of n. Possible values of n. 9 it is possible. Is 1 possible? 1 will become 21. What is the smallest number on square? I will have 21. 11 square is 121. 1 it is possible. 1 it is possible. Next one. 4. 4 will become 24. 4 into something. 4 into something, it is a possible case. 1 it is a possible case. 4 it is a possible case. 25. 4 into 6 plus 1. That is also a possible case. 5 square it is 25. 6. 6 it is not possible. Why? Because this will become 26. 26 is 4 into 6 plus 2. 4k plus 2 form. It is not possible. So 6 it is not possible. How many values n it can take? 1 it can take, 4 it can take, 5 it can take, 9 it can take. If it is taking 1, 21, 4 5s are 20, remainder 1 possible. 4, 24, 24 is, for example, 18 square it is 324 possible. N is 5, 25, 5 square is 25 possible. So 29, 23 square is 529, that is also possible. Next one, square root of 1 plus 23, 24, 25, 26. Now this is something which we did. N equivalent to 1 plus x. X is the product of 4 consecutive integers. A plus 1, A plus 2, A plus 3. What did we got in the result? N equivalent to 1 plus. We did somewhere n equivalent to 1 plus x. N equivalent to 1 plus x. See here. What is that answer we got? Answer we got, it is a perfect square. Answer we got, it is a perfect square. So answer it is a perfect rational integer. Integer plus 1. Answer will be a rational integer. I hope the idea it is very clear. Now another question. N equivalent to 1, 2, 3, 4, 5 square plus 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 6. What is the value of n? So please do not simplify it. Please do not simplify it. First thing is 1, 2, 3, 4, 5. It is an odd number. Odd number on square, it is an odd number. 1, 2, 3, 4, 5, it is an odd number. 1, 2, 3, 4, 6, it is an even number. Odd plus odd, it is an even number. Even plus even. Answer, it should be an even number. Answer, it should be an even number. Wherever odd numbers are there, please eliminate it. Wherever odd numbers are there, eliminate it. That is the first way to eliminate all incorrect answer options. This is method 1. 1, 2, 3, 4, 5 square. 4, 5 square. 1, 2, 3, 4, 5. It's an odd number. Odd number on square. Odd number. 1, 2, 3, 4, 5. Odd number. 1, 2, 3, 4, 6. Even number. Odd plus odd. Even. Even plus even. Even. Answer, it should be an even number. Option B and option D are ruled out. Another way to look at it is, suppose see here. 45 square. 45 square. 5 square 25. Unit digit 5. Here also it is 5. Here it is 5. Here it is 6. So 5 plus 5, 10. 10 plus 6, 16. 16 means either it can be 4 square or 6 square. Therefore, you can eliminate B and D like that also. Again, 5 square it is 25. Here it is 5. And here it is 6. 5 plus 5, 10. 10 plus 6, 16. 16 will come. 6 will come. 4 square 16. 6 square 36. From that point also option B and D can be eliminated. If I use the last two digits, this will become 45 square plus 45 plus 46. 45 square, last two digits is 25 plus 45 plus 46, it is 91. So it is 116. 116, it should be 16. That means n last two digits will be 45 square. 45 is 5 less than 50. 50 minus 5 square. 5 square is 25 plus 45 plus 46, which is 91. 91 plus 25. Answer is 116. So answer last two digits. I am asking about root of n. So root of 9, it is 3. 9 if square root, if I remove, it is 3 square. Answer last two digits should be 16. 1, 2, 3, 4, 6 square. 1, 2, 3, 4, 4 square. 46 square. 46 square is 50 minus 4 square. 50 minus x square and x square. Last two digits are same. So answer it is 16. So the first one will be the answer. C, option C is giving you the 1, 2, 3, 4, 4 square. 44 is 50 minus 6 square. 50 minus 6 square, last two digits will be 6 square. 6 square is 36. These elimination approach. Again I am repeating, sir. Elimination by number tree. Elimination by number tree approach. Elimination by number tree approach. Method 2. Elimination by unit digit approach. Elimination by unit digit approach. Elimination by last two digits approach. Three methods are there. You can use any method. 1, 2, 3, 4, 5 square. 45 square. Last two digits will be 50 minus 5 square. So it is 5 square 25 plus 91. 25 plus 91. 116. Last two digits has to be 16. Remove the square root. Apply squares. 46 square. 46 is 50 minus 4 square. Last two digits it is 16. 44 square will be 50 minus 6 square. Last two digits will be 36. This is one way to solve. There is another way. Method number 2. Pattern recognition. Simplify the question. Don't complicate it. Simplify the question. Don't complicate the question. Simplify the question. These 1, 2, 3, 4, 5 square. Same number is here. These one more than this number. So n equivalent to. If I keep 1 square, same number is there. Next it is 1 more than this one. 1 plus 1, 2. 2 plus 2, 4. So square root of 4, it is 2. So it is same as the last term that we added. If I replace 1, 2, 3, 4, 5 with 2. 2 square plus 2. Here again it is 1 more than. 2 square plus 2 plus 3. It is 9. Square root of 9 is 3, which is the last term. So answer for this question should be the last term. You can probably understand the pattern of the question and simplify the question by taking smaller values. 1, 2, 3, 4, 5 square, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Same number, it is getting repeated. This is 1 more than this number. 1 square plus 1, add 1, it is 2. 2 square plus 2 plus 3. 2 square plus 2, 4 plus 2, 6, 6 plus 3, 9. Square root of 9, it is 3. So it is equivalent to the last term. So answer is, it should be equivalent to the last term. I hope the logic is clear. Everybody kindly reply if the logic it is clear to you. If the logic is clear to you, kindly reply. Every question we will take 1 hour session, where in 1 hour we will discuss the concept, then we will discuss the problems based on this concept. What are the concepts that we learnt right now? A perfect square never ends with 2, 3, 7 or 8. A perfect square digital sum is always 1, 4, 7 or 9. Point number 2. Point number 3. A perfect square when divided by 4 perfectly divisible, or it gives a remainder 1. I hope the concept it is clear. These are some trial sessions that we are starting it officially from January 1st. All the enrolled students will get the regular live classes for the purchased courses. These are some classes where the student can understand my style of teaching and they can go through the content. Any doubts are there? Any doubts are there in any of the class? Kindly reply. Any doubts? Satvika, Rohit, Channakeshavulu, Pravalika, Bhavana. Any doubts are there? Kindly reply. We can also keep a track of the students who attended the session and the students who are very active. Completely the app is an artificial intelligence app. I am looking into the comments right now. Any doubts? Any doubts? I hope no doubts. Then we will be back at 12 o'clock with some more very interesting questions on perfect squares. I hope you enjoyed the class. Thanks a lot for attending the class.